Welcome back to week 6. This is Quadratics lesson 9. We are going to talk about what the difference of two squares means today, and sometimes I refer to it as dots. So our objective today is I can solve a quadratic in standard form that involves the difference, and by difference we really just mean the subtraction of two perfect squares. So first of all, what is a perfect square? So these are all perfect squares. A perfect square is basically you can take two numbers like 1 and 1, and when you multiply them together, you get a perfect square. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So on and so forth. So it's the product or the multiplication that results when you multiply a number by itself. We could also have x squared is technically a perfect square because it could be broken off into x times x. We're multiplying x by itself. So we're going to actually see that when we have two perfect squares and they're being subtracted from each other, we can use this method called dots. So what form are we in? We are in standard form. However, there's going to be no bx term. So you might be saying, Ms. Ganji, we learned how to factor when there's no bx term. We usually just do the square root method, which is fine. You could totally still do the square root method. But now I'm going to show you another method, and that is to factor it into two bubbles, so that way we can use the zero product property, the t-chart, in order to solve. So we're going to go step by step. So step 1 is to plug in 0 for y. Step 2 is we're going to find the square root of the first term. And the first term is x squared. So I just said x squared can actually be broken down into x and x. So we're going to put our 0, we're going to put our two bubbles, and we are going to put x and x into the front of each bubble. Next, we're going to find the square root of the second term. Well, the second term is 4, and we're going to take the square root of 4. The square root of 4 is 2, so that's going to go into each of our bubbles. Step 4, we're going to put plus into one bubble and minus into the other. Okay, so whenever you are factoring difference of two squares, dots, the two bubbles are always going to look the same. One's going to be positive and one's going to be negative. So now step 5 is just to use the zero product property to solve. So set x plus 2 equal to 0. Set x minus 2 equal to 0. We're going to subtract 2 to get our first x, which is negative 2. And we are going to add 2 to our second one to get our second x, which is positive 2. So when you are doing difference of two squares, you'll always have the same answer except one's positive and one's negative. So I just want to show you why this works. So let's say we were to do the opposite of factoring, which is foiling. Right? I'm going to FOIL and show you how you get x squared minus 4 back. So if I do x times x, I get x squared. X times negative 2 is negative 2x. 2 times x is a positive 2x, and 2 times negative 2 is negative 4. So you'll notice what ends up happening is the middle two terms have the same variable, the same coefficient, but they're opposites, which means that a negative 2 and a positive 2 will actually cancel each other out. And that's why it's just x squared minus 4 left over. So you could see how if you FOIL it, you'll actually get back your original answer. So let's do a difference of two squares again and follow all the steps. So step 1 is to plug in 0 for y. Okay. Step 2, right, I'm automatically going to do my two bubbles. We have to find the square root of the first term. So we need to find the square root of 9x squared. So I'm going to break this down into pieces. The square root of 9 is 3. Because 3 times 3 is 9. And the square root of x squared is x, because x times x is x squared. So I'm going to put 3x in front of both of my parentheses. Find the square root of the second term. The square root of 25 is 5. So I'm going to put 5 and 5 into my bubbles. Put plus in one bubble and minus in the other, because remember they're going to match, just have opposite signs. And now we're going to do the zero product property to solve. So 3x plus 5 equals 0 is one. 3x minus 5 equals 0 is the other. Here we have to subtract 5 first on both sides to get rid of that 5. So 3x equals negative 5. Divide by 3. So our first answer is negative 5/3. Here I have to add 5 first. So I have 3x equals 5. And then I'm going to divide by 3. And so my second answer is positive 5/3. So just like I said in the first one, same answer except one's negative and one's positive. So now I'd like you to try example 3 on your own. So see if you can solve for the x-intercepts. Okay, so I have to set this equal to 0. Okay. So first things first, I need to find the square root of my first term. The square root of x squared is x. So I'm going to put x and x into each one. Step 3, find the square root of the second term. So the square root of 121 is 11. I'm going to put 11 into each one. Put a plus and a minus into each bubble. Use the zero product property to solve. So set each one equal to 0. Here I'm going to subtract 11. So my first answer is x equals negative 11. Here I'm going to add 11. So my second answer is positive 11. Okay, last one. See if you can figure out what are the x-intercepts for example 4. So we're going to plug in 0. First, we have to find the square root of our first term, which is 4x squared. The square root of 4 is 2. The square root of x squared is x. So I'm going to do my double bubble, and I'm going to put 2x in front of both. Then I have to find the square root of the second term. The square root of 81 is 9. So I'm going to put 9 at the end of each one. One gets a plus, one gets a minus. Now we're going to do our t-chart. So 2x plus 9 equals 0, and 2x minus 9 equals 0. We're going to subtract 9 from both sides on this first one, so we get 2x equals negative 9. And then we have to divide by 2. So our first answer is negative 9/2. If you put negative 4.5, that's okay too. Here, I mean, you could do all the work, but we know what's going to happen, right? I'm going to move that 9 over, I'm going to divide by 2, and I'm going to get the exact same answer, except this time it's going to be positive. So that is how we use dots to solve a quadratic equation.